This is Group 3's final project implementation. I'm Victoria.
I'm Matthew.
I'm Brian.
I'm Caitlin. For the scenario, we are to construct a network that consists of at least 3 routers, 3 switches, 2 servers, a host for each of the 3 departments, and a host for a remote office. The servers must be connected to the switches, and the switches must also be connected to each other with one of the switches connected to a router. The routers are also connected to each other. Departments A will have 10 hosts, Department B will have 60 hosts, and Department C will have 200 hosts. Each department must be inside of a separate VLANs. The remote office will have 5 hosts and do not require a VLAN.
This is the network design we came up to accomplish this scenario. In it, Router 1, Router 2, and Router 3 are all interconnected with serial cables. Router 1 serves as the border router and also has a serial connection to the internet. Router 2 is where the majority of the VLANs for the main office are connected. Router 2 is connected to Switch 1, Switch 2, and Switch 3, while Router 3 only serves as the gateway for the remote office. Switch 1 has Department A on VLAN 10, along with the file server and database server. Although there weren't any requirements for security in this scenario, the file server and database server were placed on the VLAN 10 because it was a smaller VLAN. Over on Department B, which is connected to Switch 2, VLAN 11 has enough address space for the 60 computers. On Switch 3, Department C with VLAN 12. Department C has 200 computers, so it has the largest network address space.
For the physical connections, Router 1 DTE side in serial port 0 and connected to gigabit 0. Router 2 DCE side in serial port 1 and the DTE side in port 0, connected to gigabit 0. Router 3 DCE side in serial port 1 and connected to gigabit 0. For Switch 1, we connected Router 2 in port 24. We connected Switch 2 in port 23. We connected Switch 3 in port 22. We also connected Department A in port 21, Department B database server in port 20, and the file server in port 19. Switch 2 connected to Switch 1 in port 24. It connected to Switch 3 in port 23 and connected to Department B in port 22. And Switch 3 connected to Switch 1 in port 24, connected to Switch 2 in 23, and connected to Department C in port 22.
We named Router 1 R1. It's connected to interface serial number 0. Its clock rate was set at 2 million. The IP address was set at 10.0.10.1 with a subnet mask of 255.255.255.252. The router OSPF was 100. The network ID was 10.0.10.0 with the subnet of 0.0.0.255 in area 0. Network 10.10.0.0 with a subnet mask of 0.0.255.255 also in area 0.
Router 2 was configured with hostname R2. Interface gigabit 0 was given the IP address of 10.10.0.1 with a 255.255.255.0 subnet mask. Subinterfaces were created for each VLAN. Using .1Q trunking, subinterface gigabit 0.10 was assigned to VLAN 10 and given IP address for the router interface of 10.10.10.1 with a subnet mask of 255.255.255.240. Subinterface gigabit 0.11 was assigned to VLAN 11 and given IP address 10.10.11.1 with a 255.255.255.192 subnet mask. Subinterface gigabit 0.12 was assigned to VLAN 12 and given IP address of 10.10.12.1 with a 255.255.255.0 subnet mask. For the inter-router networks, interface 0000 was given a clock rate of 2 million with an IP address of 10.0.10.5 with a 255.255.255.248 subnet mask. And interface serial 001 was given a clock rate of 2 million with IP address of 10.0.10.2 and a subnet mask of 255.255.255.248. For routing protocols, router OSPF Zone 100 was set up with a network of 10.0.10.0 with a 0.0.0.255 wildcard mask and assigned to area 0. And network 10.10.0.0 with a 0.0.255.255 wildcard mask was also assigned to area 0.
We gave the router 3 the host name R3. It's connected to Gigabit Internet 0. We gave it an IP address of 10.20.10.1 with a subnet mask of 255.255.255.248. We connected it also to a serial interface of 1 with a clock rate of 2 million. The IP address we gave to that was 10.0.10.6 with a subnet mask of 255.255.255.252. The router OSPF was zoned in 100 with a network IP address of 10.0.10.0 with a wildcard subnet mask of 0.0.0.255 in area 0. Another network set up for 10.10.0.0 with a wildcard subnet mask of 0.0.255.255 in area 0 as well. And then we had a third network set up with the IP address of 10.20.10.0 with a wildcard subnet mask of 0.0.0.255 in area 1.
For the switch 1 configuration, we named it SW1. The interface Gigabit Ethernet 19 was configured for access to VLAN 10. The Gigabit 20 was configured for VLAN 10 as well as the Gigabit 21. For the interface Gigabit Ethernet 22, 23, and 24, they were configured for trunking using .1Q encapsulation.
For switch 2 configuration, we use the interface Gigabit Ethernet 22 to be assigned access to configure VLAN 11. Interface Gigabit Ethernet 23 and 24 use trunking for encapsulating .1Q.
Switch 3 configuration. We gave switch 3 the name SW3. We connected this to Gigabit Ethernet 22 and we configured access for VLAN 12. In Gigabit Ethernet 23 and 24, we configured it for trunking using the 1.Q encapsulation method.
Department A, server configuration. They have 10 PCs, a database server, and a file server with the IP address 10.10.10.0/28 and a gateway of 10.10.10.1, also with a subnet mask of 255.255.255.240. For Department B configuration, they have 60 PCs with the IP address of 10.10.11.0/26 and the gateway of 10.10.11.1, following with a subnet mask of 255.255.255.192.
For Department C configuration, there were 200 PCs, and the IP address was 10.10.12.0/24. The gateway was 10.10.12.1, and the subnet mask was 255.255.255.0. For the remote office configuration, there are 5 PCs. The IP address 10.20.10.0/29 with a gateway of 10.20.10.1 and a subnet mask of 255.255.255.248. In conclusion, we were able to implement a network which successfully accomplished the goals of the scenario for this project within 30 minutes. The subnets were chosen to accommodate the number of computers and servers for each department. As there were no access limits for the servers, no access lists were necessary. No other special technologies were implemented in the execution of this project.